Welcome to this Skill Builder session on one-way ANOVA. This session focuses on how to test a hypothesis using a one-way analysis of variance. I will explain when we can use this type of test, as well as the assumptions that your data must meet. If you're already familiar with the t-test, you'll know that it's used to determine whether there's a significant difference between the means of two groups. The ANOVA can be considered an extension of the t-test. Instead of only comparing two groups, it allows us to compare the means of three or more groups. The dependent variable must be quantitative and the independent variable must be categorical. Some examples of situations when we would use an ANOVA to test for significant differences between groups might be that we want to test the differences in blood pressure between different groups of people, such as people who engage in low, medium or high levels of exercise. So exercise level would be the independent variable that has three categorical levels, low, medium and high, and blood pressure is the quantitative dependent variable. Another example here is testing which type of social media affects hours of sleep, where type of social media is the independent variable and hours of sleep is the dependent variable. So we could compare three or more types of social media, such as Instagram, TikTok and Facebook, or even add more to this like Twitter. So the categorical variable of social media type could have three or more levels. Hours of sleep is the quantitative dependent variable. The results of the one-way ANOVA will give you some useful values, including the F value and the associated P value. A larger F value indicates there are larger differences between the group means relative to the variability within each group. The P value indicates the probability of observing an F value as extreme as the one calculated from your data if the null hypothesis is true. Typically, if this value is less than 0.05, the null hypothesis is rejected and the experimental hypothesis is accepted. Before you do an ANOVA, there are some assumptions or requirements that your data must meet. These include independence of observations, meaning that each observation or data point within each group should be independent, or in other words, each data point should not be influenced by any other. And the groups themselves should be independent of each other. For example, there must be different individuals in each group with no individual belonging to more than one group. An assumption that's particularly crucial for ANOVA is homogeneity of variance, as this affects the validity of the F value. Homogeneity of variance means that there is an equal spread of scores around the mean within each sample. Homogeneity of groups means that each group should be similar in terms of variability, distribution shape and sample size. It also assumes normal distribution or normality. The distribution of the data within each group must be approximately normal. We've now covered the basics of the one-way ANOVA, which is used to compare the means of three or more groups and has one independent variable. There are various extensions of the ANOVA model that can accommodate different study designs and research questions. There are lots of possibilities, and some examples include a two-way ANOVA, which can be used to study the simultaneous effects of two independent variables on the dependent variable. A three-way ANOVA involves three independent variables. A repeated measures ANOVA can be used to compare the mean scores of a sample at different time points or in different conditions. And multiple analysis of variance, or MANOVA, is appropriate for the analysis of multiple dependent variables. And there are many more ways to adapt and expand the basic ANOVA model to answer different research questions. For guidance on the broader range of stats tests, please go to the Skills for Academic Success website at kent.ac.uk/SAS, where you can view more of our numeracy and statistics videos. You can also book a one-to-one appointment with one of the SAS team.